All right, let's just dive right into this. Welcome to This Explainer. Today, we are taking on a bit of a notorious challenge from the November 2023 higher tier math paper, question 18. And we aren't just hunting for a single right answer here. Nope. Instead, we're going to chart literally every single valid pathway to full marks, using the exact wording directly from the official mark scheme. So if you've ever looked at vector proofs and felt entirely intimidated, hey, you're in exactly the right place. Let's do this. Here is our quick roadmap for the explainer today. We'll start by unpacking question 18. Hit the first mark by finding edges, move on to the second mark, which is the long path, grab the third mark by connecting midpoints, and finally, complete the proof before reviewing all valid pathways. Okay, step 1, unpacking question 18. Now just look at how much information is packed into these few short sentences. We're given a quadrilateral, A, B, C, D, along with 4 midpoints, E, F, G, and H, on their respective sides. We also have 3 initial vectors to work with right off the bat. Vector AH is A, vector AE is B, and vector DG is C. So what is our ultimate goal here? Well, we have to prove, strictly using vectors, that connecting those 4 midpoints, E, F, G, and H, creates a perfect parallelogram. I know, it sounds like a lot. But remember, every midpoint effectively cuts a side exactly in half. And honestly, that's your secret key to unlocking this whole puzzle. Moving on to the next section. First mark, finding edges. To actually secure this very first mark, you just need to successfully find one of these 4 immediate adjacent edge vectors. Just one. Notice the power of the word "or" in the mark scheme here. It's totally up to you. You could figure out vector EH by going from E to A, which is negative B, and then A to H, which is A. That gives you minus B plus A. Or, hey, if you prefer going the other way, vector HE is minus A plus B. It's the exact same logic on the other side, too. Vector HG is A plus C, and reversing that gives you vector GH, which is minus C minus A. Literally any single one of these 4 explicit expressions immediately banks you your very first point.
Next up, section 3, second mark, the long path.
So this next step is all about finding the vector for the unlabeled side. To get from B to C, we literally have to travel all the way around the other 3 sides of the shape. From B to A, then A to D, and finally D to C. Now, because we already know the midpoints, we absolutely know the full sides are exactly double the half sides. So doing the math, vector BC is minus 2B plus 2A plus 2C. And this brilliantly illustrates how direction dictates our signs. Journeying from B to C gives us that first expression, right? But taking the exact inverse path, from C to B, flips every single sign. That gives us 2B minus 2A minus 2C. And the great news, the mark scheme happily accepts either of these long paths for your second mark. All right, rolling right along to section 4, third mark, connecting midpoints. Okay, so for the third mark, you connect the remaining midpoints using that long path answer we just found. Let's look at vector EF, for instance. To get from E to F, you go from E to B, which is B, and then halfway along that long path BC we just calculated. And you know what? The algebra simplifies just beautifully here. B plus 1/2 of minus 2B plus 2A plus 2C simplifies all the way down to simply A plus C. But wait, there are options. The mark scheme also completely accepts the exact calculations for vector FE, resulting in minus A minus C, or vector FG giving minus B plus A, or even vector GF giving minus A plus B. You literally just pick the one that opposes the edge you chose for your very first mark. It's really that straightforward. Almost there. Section 5, final mark, completing the proof. So the absolutely crucial point here is recalling our core vector definition of a parallelogram before we lock in that final mark. Remember, for a shape to actually be a parallelogram, we must prove that 2 vectors representing opposite sides are exactly equal. In the vector world, if the algebraic expressions are identical, it mathematically guarantees that those lines are perfectly parallel to each other and exactly equal in length. That's the whole shebang. And here is the official wording required to get that 4th and final communication mark. You have to state this exact equality to explicitly prove to the examiner that the opposite sides are indeed equal. So, if you mapped out edge EH earlier, you'd match it with FG, explicitly writing out EH equals FG. Or, if you went the other route, you'd write HG equals EF. Following that up with a really clear concluding statement that says EFGH is a parallelogram, boom, that seals the deal. Full marks.
Finally, section 6, reviewing all valid pathways.
Okay, let's take a step back.
By breaking this incredibly intimidating algebra down into these 4 logical steps, you can confidently choose your own valid pathway through the proof. You don't have to guess the one single right way, because there isn't just one. The mark scheme is incredibly flexible. Find an initial edge, traverse the long side to find the inverse, connect the midpoints opposite to your start, and explicitly state that equality. It is a perfect, repeatable framework that works every single time.
As we wrap up this explainer today, I want to leave you with a question. Ask yourself, once you know how to mathematically map these vectors on a page, can you start visualizing these invisible geometric forces shaping the physical structures in the real world around you? Seriously, understanding the hidden math of midpoints and parallel lines kind of changes how you see everything. Thank you so much for exploring this 4-mark journey with me. Keep practicing those pathways, and you'll have this totally mastered.